Hello and welcome to day 20 of learning ML from chatgpt. So let's get started. So yesterday we learned about autoencoders and anomaly detection. So this was basically when we had an encoder which we encoded our data, then we tried to reconstruct the data if there are any errors that are present in the process of constructing data. We know that this was an anomaly. Okay, and then we used the MNIST data set and there were no anomalies in the MNIST data set because it's so widely used that okay, so now let's get started with day 20. Let's see. So day 20. Unsupervised learning with clustering. K-means clustering, hierarchical clustering, and dimensionality reduction. Implementing clustering algorithms using scikit-learn. Apply clustering to a real-world dataset and analyze the results. Okay. So please give me day 20's lesson. Okay. Let's see what all this clustering is about and how we can perform it. Okay, clustering. Clustering is an unsupervised learning technique used to group data points into clusters, where similar data points are grouped together. Unlike supervised learning, clustering doesn't use labeled data but finds patterns based on the data structure. Okay, types of clustering. A K-means clustering. K-means is a popular algorithm that partitions the dataset into K distinct, non-overlapping clusters. It iteratively assigns each point to the nearest cluster centroid, recalculates the centroid, and repeats the process until convergence. Okay, so just to wait. Okay, sorry for that. And is a popular algorithm that so we have K distinct clusters, and we have what's a cluster centroid? What is a okay? So iteratively assigns each point to the nearest cluster centroid is the center point of a clustering algorithms. It represents the mean average position of all the data points within that cluster. The centroid acts as a reference point to determine which data points belong to a specific cluster. In algorithms like K-means clustering, the goal is to minimize the distance between data points and their corresponding cluster centroids. Here's how it works in K-means. The algorithm initializes the centroids randomly or through a specific method. Each data point is assigned to the nearest centroid. Okay, so I guess this is the nearest value that which of the centroids is the nearest value to the data point. Centroids are recalculated as the mean of all the points in the cluster. Step 2 and 3 are repeated until the centroids stop changing significantly. Convergence. Okay, I get that. So yeah, so we're adding it to a cluster where the centroid is going to be the average of all the clusters, all the data points in the cluster, and we keep iteratively doing that until there's no significant change, and this is called convergence. Now if we go back to where we were. This was autoencoding. Okay, hierarchical clustering. There's a hierarchy of clusters either by agglomerative, a bottom-up, or divisive top-down methods. Okay, it produces a dendrograph, tree diagram, showing the arrangement of the clusters formed. Okay, so this is K-means is just like averages and like nearest cluster. This is hierarchical. So dimensionality reduction techniques like principal component analysis, BCA, reduce the number of features while preserving the important structure of the data. So yeah, this is I think L1 regularization. This reduces the number of features whilst preserving the important ones which have the greatest weight, like the bias. Was it? Yeah. Dimensionality reduction can be used before clustering to visualize high-dimensional data or improve clustering performance. Okay, so where we just we don't want to cluster like unnecessary data that has no impact on the like the last feature vector, which is the result what we want to predict. Okay, code examples: implementing clustering out using scikit-learn. K-means, numpy, matplotlib, make blobs. What's this? Create synthetic dataset with full cluster. Okay, I assume it's just scikit-learn's way of creating, like, yes, it's called synthetic data. Okay, make blobs, 500 samples, centers 4. Oh, okay. So this will group it into 4 different clusters. K-means equals K-means, clusters 4, random state 42, K-means fit, so this is where we train it. And YK-means equals K-means dot predict centroids, K-means dot cluster centers, and then we're going to cluster. No, we're going to print using or display them using matplotlib, the cluster. So what's this all about? Is this from the end to? Okay. YK means map verdis. I'm going to ask it to explain this line by line. Please explain these code snippets line by line. And to the hierarchal, and oh, we're using the iris dataset. Nice. I'll just read through the other ones as well. Okay, so I just said this is just plotting results. Okay. SkiPy. What's SkiPy? SciencePy, I assume. Cluster hierarchy. Dendrogram. Okay, so I assume this is for like scientific used for scientific purposes, like plotting data. We have this for plotting the like tree diagrams, which are called dendrograms for the hierarchical clustering. So we're making blobs this time with 150 centers 4. So linked equals linkage x ward. Apply hierarchical clustering, agglomerative. Okay. Figure 10/6 dendrogram linked. Okay. And finally this one. So we're having the iris dataset, PCA, reduce the dimensions, and okay. So the task: apply clustering to a real-world dataset and analyze the results. The iris dataset, the more customized dataset, or any other dataset clustering potential of the suggested datasets. Pre-process the dataset if necessary, scaling, handling missing values, apply k-means and hierarchical clustering algorithms to the dataset, analyze and visualize the results, use PCA to visualize the clusters, experiment with different numbers of clusters and linkage criteria in hierarchical clustering. So we go back down here, we'll see the okay, I get this part. Make blobs. So it generates a synthetic dataset with 500 samples and 4 centers. The X variable contains features, coordinates, and Y true labels. Which cluster each point belongs to. Random state ensures the dataset is generated the same way each time. K-means initializes the K-means clustering algorithm with 4 clusters and a fixed random state for reproducibility. Then the k-means algorithm fits the k-means algorithm to the dataset, will assign each point to one of the 4 clusters and compute their clusters. So compute their cluster centroids. And then predict assigns each data point in X to a cluster and stores the cluster labels in Y. K-means centroids equals k-means dot cluster centers, exact coordinates of the centroids of the 4 clusters. Okay, so plots the data points in X on a 2D scatter plot. coloring them by their assigned cluster using the Verdis color map. Okay. Okay. The points size is set to s equals 50. Okay. So plt.scatter plots the centroids on the same scatter plot as red crosses and there was some as centroids. plt.title k-means clustering as title of the plot. Yeah. Legend displays the legend for the plot. Okay, and red is the plot. So second one, I'll just skip this one. Iris loads the dataset. Yeah. PCA initializes PCA to reduce the dataset from 4 dimensions to 2. Okay. Right. XPCA equals PCA.fit transform applies PCA to the Iris dataset. X reducing its dimensionality to 2 components which are stored in XPCA. So here we're creating a 2D scatter plot using PCA reduced data. The points are colored by the true labels representing as Iris species as the title of the plot. Labels the X and Y axes with PCA component 1. Okay. I just want to go back. Oh. Okay, so techniques like principal component analysis reduce the number of features while preserving the important data structure. Dimensionality reduction can be used for, before clustering high dimensional data or improve clustering performance. Okay, so now I'm just going to paste these into Google Colab and I'll run these and see the visualizations to help give a better grasp of the topic. I'll just add, so this is k-means clustering. Oh, okay. So these are the k-means clusters. The X are the centroids. So we see there, we've got a few like outliers, but they are assigned to the correct data set. Yeah. Okay, that's good. And now I'm going to not code, it's text. So this one is the hierarchal data set, clustering. Hopefully we'll see a nice like diagram of the dendrogram, however it was called. Oh, that the units at the bottom are way too small to see. The x-axis. Okay, so this shows the so if we can refer back to, are they different colors? And yeah, these are like one data set, another data set. No, one cluster, another cluster, and another cluster. I assume blue is another cluster, which has hierarchy over all the other ones. And finally, I'm going to do the dimensionality reduction. Let me just dimensionality reduction. So this is where we just remove the features that aren't needed from the data set, and yeah. So we're okay. Let's do this. So it looks like we've removed one of them, which looks like the green one. Okay, because this, remember, it reduces the amount of features. So, yeah, wait. I think I'll end the lesson here, so thank you for watching, and I'll see you in the next video. Goodbye. Yeah, bye. And thank you for 50 subscribers, by the way. Goodbye.